Alaska, land of extremes. This is America at its most rugged, forged over millions of years by geological forces. Here, extreme geology creates extreme weather. It's a deadly combination, making Alaska a dangerous place to live and work. And the impact of Alaska's extremes doesn't stop at the state line. What happens here strikes people around the world. This is the story of nature at its most extreme. Exploding volcanoes, massive glaciers, towering mountains, howling winds, freezing temperatures, devastating earthquakes. Calling Alaska extreme is an understatement. This is Alaska today, America's biggest state, jammed against the Arctic Ocean. 670,000 people spread out over 663,000 square miles of wilderness. That's about one person per square mile. Superimposed on the lower 48, Alaska stretches from Florida to California, from Canada to Mexico. But geologically speaking, Alaska is young and still changing. There are 5 basic parts to Alaska, each extreme in its own right. The North Slope, home to America's largest oil field. The Aleutian Arc, a chain of explosive volcanoes. The Alaska Range, with the continent's highest mountain. The Bering Sea, one of the world's most productive and dangerous fishing grounds. And the southeastern glaciers, made up of trillions of gallons of frozen freshwater. Each part of this epic landscape has its own story of violent forces acting ceaselessly over millions of years. And each part poses a unique threat to Alaskans and to people all over the world. Phase 1 of building the Alaska we know today, constructing the North Slope. The North Slope lies above the Arctic Circle. Because of the tilt of the Earth's axis, for 2 months every year the sun never rises, and the ground never thaws. The North Slope covers nearly 90,000 square miles, an area about as big as Nevada, but fewer than 7,000 people call it home. This harsh environment is better suited to caribou than to people. And like Nevada, this frozen desert receives less than 6 inches of precipitation per year. Massive snowfalls aren't likely on the North Slope. The mountains to the south block all the moisture. But what snow does fall stays and piles into large drifts. Like wind-blown sand, this snow is dry and cutting. A treasure is buried deep below the ice and snow. Liquid oil. 800,000 barrels of oil a day come from the North Slope, 16% of all U.S. production. But extracting the oil can be dangerous. Battling the bitter cold elements has its challenges.
I've been up here when you couldn't even see where you were going. The wind was blowing so bad and the snow was blowing so hard around you. All you were doing was bouncing off the guardrail and bouncing into the ditch. When it's bad, it's really bad.
Today, the North Slope is an Arctic desert with wind-blown snow and sub-zero temperatures. But once, this frozen land was a temperate sea. warm waters filled with prehistoric life. Think dinosaurs, not polar bears. How did the North Slope get from this to this? Nature's most powerful geological force holds the answer: the movement of the Earth's crust. The Earth's crust is cut up into massive chunks called tectonic plates. These plates are in constant motion, shaping and reshaping continents and oceans. Spin the Earth back in time and set the clock at 250 million years ago. Alaska as we know it disappears because of the movement of tectonic plates. What will become the North Slope is a shallow sea filled with microscopic plants and animals. When these organisms die, they fall to the seafloor. There, over millions upon millions of years, they are buried by layers of sand and mud. In a geological pressure cooker, the hydrogen and carbon in the remnants of these creatures are squeezed out, molecule by molecule, transforming them slowly into that precious sludge we call oil. But why the shift from warm to cold? For millions of years, Earth's temperature has swung from hothouse to icehouse in a natural cycle related to the amount of carbon in the atmosphere. 250 million years ago, average temperature on the North Slope is a balmy 68 degrees. Today, it has plummeted to an average of 10 frigid degrees. This ancient sea has been replaced by ice and frozen ground. The oil is still here today, at depths below 3,000 feet. Extracting it without damaging the wilderness is one challenge. Fighting the weather, another. And sometimes it's deadly. Cutting through this frozen former seabed is the only road in and out of the oil fields, the Haul Road. From Fairbanks in the south to Prudhoe Bay at the edge of the Arctic, the road stretches over 400 miles, most of it gravel. Every nut and bolt used to keep the oil field going travels this road by truck. The drivers who run this road face high risks. Every winter, hurricane-force winds slam the slope. The slope is in the direct path of a brutal global weather pattern called the Siberian Express. Many storms start in Siberia and pick up steam as they move east. Because it was once a flat seabed, the North Slope offers no contours to block the wind. At their worst, winds here can reach 100 miles per hour. With wind chill, temperatures can plunge to minus 135 degrees below zero. These are the legendary North Slope blows. On the oil rigs, they call it Phase 3. All but emergency workers must stay indoors. Whiteouts obliterate the road surface. Man-made equipment breaks down. Steel fractures. Exposed skin freezes instantly. Everything comes to a halt. The Haul Road shuts down. Some truckers are waylaid and others stranded for days at a time. Emergency crews work around the clock to rescue them. And the impact of a North Slope blow doesn't stop in Alaska. With help from the jet stream, the deep freeze moves south, and Alaska's chill can travel all the way to the lower 48.
Challenger, go and throttle up. Roger, go and throttle up.
This Arctic air may even have contributed to one of America's worst disasters. On launch day, January 28, 1986, the temperature at Cape Canaveral is close to freezing.
10, 9, start, 4, 3.
The cold causes undetected damage to critical seals in the Space Shuttle Challenger's booster rocket. 73 seconds after liftoff, Challenger explodes, killing all 7 of her crew. The Arctic cold's contribution to this tragedy is just one example of the lethal reach of the Alaska effect. Extreme events here leading to extreme outcomes thousands of miles away. Extreme weather, extreme geology, and an extreme wealth of natural resources. That's Alaska in a nutshell. The very geology that makes Alaska's economy run makes it a risky place to call home. Over millions of years, the North Slope, the first piece in building extreme Alaska, is transformed from seabed to frozen land. But the tectonic forces don't stop there. Around 45 million years ago, a long chain of volcanoes vaults into the sky. This is the Aleutian Arc. Today, the Aleutian Arc is a string of islands made up of at least 40 active volcanoes, the highest concentration in North America. The Aleutians extend like a spider's limb from the mainland of Alaska. From east to west, they span nearly 2,000 miles. That's about the distance between New York and Denver. This is an explosive part of the planet. Every year, Alaska is rocked by at least one major eruption. In 1992, Spur Volcano blows. Alaska's biggest city, Anchorage, is hit hard. Spewing ash shuts down schools and businesses. Jet flights over Alaska are canceled. Cleanup costs soar to the millions. But some Alaskan volcanoes are so remote that few people witness their eruptions. In 2006, Cleveland volcano blows. The ash cloud reportedly reaches as high as 20,000 feet into the atmosphere, where it's witnessed by astronauts aboard the space station orbiting hundreds of miles above the Earth. The Aleutian volcano peaks can reach over 9,000 feet above sea level. But underwater is where these towers of fire are built. Spin the Earth back 45 million years ago to a time when the volcanoes emerged as an underwater trench. This trench is where two pieces of the Earth's crust, the North American plate and the Pacific plate, converge, and where these volcanoes are born. Where the crusts collide, denser oceanic crust moves under lighter continental crust. As the water-bearing oceanic crust moves down, it triggers the melting of mantle rock, creating magma. Over time, the magma moves up from deep inside the Earth to the surface. The magma can emerge as hot red lava that flows like a river or spurts like a fountain. But more often, it explodes. Volcanoes explode because the magma contains high amounts of water vapor. Picture valves on steam pipes. When the water and dissolved gases in the rock reach the surface, they suddenly expand into steam. Steam is a gas, and its pressure shoots rock and ash miles into the air. Many volcanoes are built from the top down. Rock spews out of the central vent, and gravity brings it down the slopes. The Aleutian Islands begin as underwater volcanoes that over time emerge from the seafloor. Despite the danger, people have lived on these volatile islands for centuries. When a volcano blows, the costs are high. June 6, 1912. 300 miles southwest of Anchorage on the Alaska Peninsula in the Katmai region, Nova Rupta, a nearly 3,000-foot tall volcano, explodes. It's the largest volcanic eruption of the 20th century. At the center of the eruption, the volcano's summit becomes a crater 2 miles square. In a 40-square-mile area around the volcano, pulverized stone piles up more than 600 feet high. Sulfur dioxide makes the water undrinkable, the air nearly unbreathable. Entire forests are stripped clean in an instant. Nearly every living thing in the eruption's path is suffocated by tons of ash.